Presentation in our properties units is what's your properties notes. Intellectual property has the shelf life of a banana by Bill Gates. So the learning goals for this particular presentation that you be able to define and give examples of physical properties for substances, and that you be able to differentiate between samples based on the physical properties. So, what we already know. We already know that metals and nonmetals have different properties from earlier grades. We know that there's something called luster, which is the shininess of a rock. We know that certain rocks are conductive of electricity and others aren't. And we know that certain ones are malleable, which means that they can be bent into different shapes. And you can use these properties to classify rocks from earlier grades. So now what we learned in the lab. We learned in the lab that properties can be used to compare one substance to another. You can differentiate between what this substance is, what this substance is, and what this substance is based on the physical properties. Okay, you can look at this one and say it's pretty granular and this is more of kind of a paste. You can say color is a differentiation, but we said that substances can be classified based on their physical properties. And this classification helps us organize our knowledge and kind of talk a little bit more about what the substances are. Now, a physical property is something that is defined as a characteristic of a property that can be measured independent of any other substance. So if I were to take a look at this and I were to measure this substance independent of anything else, that means I'm not mixing it with anything, and that usually includes things like air and water and those sorts of things that you're measuring it independent of anything else. An example of a physical property is color, and that's one that we can use to distinguish between these three samples. You have one that's kind of a whitish greenish color, you have another one that's red, and another one that's yellow, and so you can differentiate based on these three substances just solely on color. Now, there's lots of other physical properties, and we're going to go through them. Now, the first one that we have is magnetism. You should be familiar with magnetism. It's whether something is attracted or repelled to a magnet, and what that usually does is usually indicates the presence of iron, nickel, or cobalt in a sample. Those are the three things that are magnetic without anything else being done to them. So, magnetism is an example of a physical property because you can measure it without anything else. And some people say, well, there's a magnet there. Yes, that's the tool that you're using to measure it, but it's not like you have to mix the substance with air and then use a magnet. Next, you have mass. Mass is the amount of matter that an object contains. We usually think of it as it's got a little bit different definitions from the physics part. Physics we talked about in terms of inertia, but in the chemistry part of it, we're talking about the amount of matter or how much stuff there is. All objects have mass. Okay, every single atom that you have, and we'll talk about atoms later, but every single atom has mass, and everything is made up of atoms. So since every atom has mass and everything is made up of atoms, all objects will have mass. Now, mass is not directly measured with a scale. Okay, you may think of this and say, well, this tells me the mass, and you're right, it does. But what it does is it has a spring that actually measures the gravity and then the gravitational force, and then it converts that into mass. Now, in order to directly measure mass, you would need one of these sorts of things, which is called an inertial balance. We tend to not have those, so we say that mass is measured with a triple beam balance, even though it's not directly measured with a triple beam balance. It's kind of a little tricky. So now we have length, area, and volume. All of those are units of length, either in 1, 2, or 3 dimensions. So length is the longest distance of an object. So if you were to look at some sort of thing right here, you'd have to find the longest dimension, and that would represent the length. The height is always the third dimension, or the vertical, and then so this right here would be the depth. So the longest distance is always referring to the length. Okay, area is length in 2 dimensions, volume is length in 3 dimensions. The malleability of an object, as a review, is the degree to which an object can be restraight by striking. So generally it's how much can you bend this particular substance. Can you pound it into very thin sheets? Metals are generally pretty malleable. You can actually get them to work very well, especially when you heat them. Whenever you heat them, it makes it even easier. Other substances generally are not malleable. They tend to shatter. Like if you were to hit glass with a hammer, it would shatter, it wouldn't bend. So they're not malleable. Density is another example of a physical property. Density is a ratio of mass and volume. We're going to talk about that a little bit later in this presentation. It's a measure of how compact the atoms are in a molecule. So, for example, are the atoms right next to each other? Because this would be extremely dense, or are they more kind of spread out with gaps in between? Okay, an example of this is if you have something that's really heavy, like metal, it will sink in water, whereas ice will float. So that tells you a little bit about how compact the molecules are. Another example of that is gold is very dense. So if you see gold, it will sink to the bottom of the ocean, whereas nitrogen is not. If you have nitrogen, when it's released in the air, it will actually float into the air. Next, we have boiling point and freezing point. Those are the temperatures at which a substance changes phase. We're most familiar with it in terms of water because we use boiling water a lot to cook. And so we know the temperature at which water boils is 100 degrees Celsius or 212 degrees Fahrenheit. Okay, so we're going to say 100 degrees Celsius. And then the temperature at which ice melts is 0 degrees Celsius. So that's the temperature at which it changes. Now, it's different for water than it is for, say, nitrogen gas, or it's different than it is for, say, gold. So that's a physical property that can be measured independent of something else. Other examples of physical properties are color. In other words, what light does it give off? For example, if you were to look at this substance that I'm drawing right here, it gives off red light, where if we changed it to something like this, it would give off green. Okay, and that's an example of a physical property. Solubility is another thing. Does it dissolve in water? Okay, if you've ever tried to cook and you mix oil and water, you know that they don't mix, and so it doesn't dissolve very well. Ductility is, can you reshape a metal into a wire? That's another example of a physical property. Brittleness, can you break it real easy like glass? Thermal conductivity is, can heat flow through it? So, for example, we make our pans out of metal because heat can flow through the metal very easily. Now, if we were to make our pans out of wood, it wouldn't work very well because the wood will actually block the heat and we wouldn't be able to cook our food as efficiently. And finally, we have specific heat, which we'll talk about later in this term, which is how much energy is required to change the temperature of a substance. So some things are really easy to change the temperature of, like we talked about before with metal, and some things are really difficult to change the temperature of, like wood. There's lots and lots of examples of physical properties. The key to physical properties is saying, is there a way that I can measure this without something else? I don't have to react it with something, or I don't have to change it in this way. Then it's going to be a physical property. So here's an example. The first one says define the term property in chemistry. So you see an example of a property, but that's a real estate property. So when we refer to property in chemistry terms, we're talking about a characteristics that's used to describe something. Now, so far we've talked about physical properties, but we will talk about chemical properties as well. So it's a characteristic that's used to describe the behavior or the appearance of a particular substance. Next, list 5 physical properties that define you. This is going to be up to you to define, but it's something that you can measure independently of something else. So you wouldn't say something like, oh, I get along really well with people. And the reason why is that depends on your interaction with somebody else. So physical properties could be something like, oh, I'm happy, or I'm really tall, or I'm short, or I have brown hair, or something along those lines would be examples of physical properties that define you, but you can't do it in relation to somebody else. So you can't just say, oh, I'm really good with people, because that's an example of you interacting with somebody else. Next, it says an archaeologists uncover what they believe to be an original copy of the Magna Carta from 1215. What type of properties should be examined given this unique artifact? So, if you're looking at the physical properties of this thing, you want to measure how it is independent of something else. You don't want to take, let's say, acid and say, hey, if I pour the acid on the paper, then it's going to do something. So you really want to examine the physical properties. Now, if you're looking at the physical properties of this thing, you'd want to look at the color. Okay, you may want to look at somehow if you can figure out the age, the length, the ink. What color is it? What color is the ink? What color is the paper? Those sorts of things are things you're going to examine. You don't want to measure what we're going to call chemical properties because that would destroy part of the sample.